Hey guys, congratulations, you've made it to physics. So today we're going to be talking about static electricity, but before we start into static, we have to talk about charges, which means, congratulations, we have to go back to when we did chemistry. So there are three parts of an atom. There's protons, neutrons, and electrons. Two of these have charges. Protons are positive, electrons are negative, and neutrons are neutral. But we also have to look at where they're found. So in my atom, in the nucleus, I have my protons and my neutrons. And then around that, I have my electrons. Because the electrons are not part of the nucleus, and because they're found around the nucleus in these shells or energy shells, we can actually move our electrons, but we can't move our protons or our neutrons. This is something that we looked at when we were looking at chemistry. You could give or take electrons depending on what the element was, but you couldn't change the protons or the neutrons. Because of this, we actually get things like static electricity, and electricity is actually the movement of the electrons or energy using the electrons. So again, let's go into, we talked about how opposites attract, likes repel. So this is how we explained as you went from left to right on the periodic table, even though you were gaining protons and gaining electrons, if you looked at the atomic radius, it was actually getting smaller and smaller and smaller. That's because with the bigger number of protons and bigger number of electrons, they were actually attracting each other more and more and more. Because opposites attract. Well, the one thing that we didn't talk about was the fact of neutrals. So neutrals are attracted to charged objects. So the main three things, opposites attract, likes repel, and our neutrals are attracted to charged objects. So, charging, well, there's two different charging that we're going to look at. There is charging by friction, and this is something you guys have probably all done. This is rubbing the balloon on your hair. This is rubbing, combing your hair when it's really dry out. A lot of you guys were putting dryer sheets in your combs and your brushes. This was actually to prevent charging by friction. So charging by friction is charging material by rubbing it against another object. So when electrons are rubbed off the material, it becomes positive, and the material that gains electrons becomes negative. One example of this is actually something we saw last night on Monday. In a cloud, you can actually end up getting a separation of charges. And when you have the separation of charges, sometimes what happens is these clouds discharge and ground themselves onto the ground, which gives us lightning. So Monday night, if you were in College Heights, we had some lightning. And this is actually one of the most dangerous types of static electricity. So, if you have an uncharged material, it means what? Well, if it's uncharged, it means it's neutral. Which means, again, what? It means that it has the same number of protons as it has electrons. What you can do is you can actually take two objects that are uncharged, that are neutral, and you can rub them together. And what happens is depending on what the objects are, so say this one's a paper towel, and this one is an acetate strip, which means a strip of plastic. When these are rubbed together, electrons are actually transferred from one of them to the other. Again, remember that the protons can't move. The protons will stay the same. But the electrons can move. So this one will keep the same number of protons because, again, they can't move. But it'll actually lose some electrons, so it won't have as many. This means that this paper towel becomes positively charged. And this acetate strip, again, the protons stay where they were. But this one's actually gained those electrons from the paper towel, which means now there's more electrons than there are protons, which means this is now negatively charged. So different materials will actually gain or lose electrons or different amounts of electrons. And this is called the electrostatic series. This is actually in your data table, and it shows an order of the weaker tendency to gain electrons to the stronger tendency to gain electrons. This means that if it has a weaker tendency to gain electrons, it's more likely to lose them. If it has a stronger tendency to gain electrons, well, then it'll most likely gain them. The further apart items are on the electrostatic series, the more electrons they'll lose or gain. So human skin is at the top. So if we have our plus for weaker, And near the bottom we have our minus because this is our stronger tendency. So remember, it's minus because if it gains electrons, it's going to be negatively charged. And again, this is all going to be in relation to each other. Just because it's on this end doesn't mean it can't gain electrons. It just means that it's less likely to. So human skin is the first one. Rabbit fur. Acetate. Glass. Human hair. Nylon. Wool. Cat fur. Silk. Paper. Cotton. Wood. A rubber balloon. Vinyl. Polyester. Okay, so a common one that you guys have probably done in your lifetime is to take a rubber balloon and rub it on your hair. So if rubber balloon is at the stronger tendency to gain electrons, that means the rubber balloon will become negatively charged. And the human hair will become positively charged. Well, the cool thing about this is, so when you take that balloon and you've rubbed it against your hair, what happens to your hair? It sticks straight up. Why does it stick straight up? Well, what happens is when you've transferred the electrons to the balloon, it means that you have more positive than negative on your hair. I mean, you'll still have a few negative, it won't strip all of it, but what happens when you have a positive hair next to another positive hair? Well, positives or likes repel. So when you've stripped the negatives out of your hair, the protons will actually repel each other, which is why it'll stand up, which is kind of cool in my mind. The other cool thing you can do with this is that you can do this with a comb or with a balloon, and you can put it towards water. So if you take your water faucet, and we would actually do this in class, and you had water coming out, and you put this charged balloon, once you rubbed it on your hair, what would happen is this water, which is neutral, would be, well, what did we say? Neutrals are attracted. So this water would actually bend towards the balloon. And this is called charging by induction. So what's happening here is that the water is neutral. There are an even number of positives and negatives in the water. But what happens is when you bring this negatively charged balloon near the water, the negatives in the balloon will repel the negatives in the water. and the electrons will actually move to the far side. So in this, you'll end up, your positives won't move because they can't. They're in the nucleus. But your negatives will all flee to the far side, as far away from the balloon as it can. So when that happens, this side of the water, right here, pretends to be positive. And when it pretends to be positive, and this is negative, well, opposites attract. So it'll actually be attracted to the negative balloon. So even though the water is still neutral because it has the same number of protons as electrons, it's going to pretend like it's charged and act as if it is. So charging by induction is different because there's no contact. You don't actually have to touch it. And you need a charged object to do it. Whereas with charging by friction, both materials can be uncharged, but as soon as you rub them together, it becomes a charged object. This is also how, when you rub a balloon on your head and stick it on a wall, it sticks. It's because that charged balloon is making the wall pretend as if it is charged, even though it's neutral. So, that is all we're going to be covering today or this week. You will have a worksheet on static electricity. Do remember, protons don't move. So on the second page, there is a diagram that shows you a meter stick on top of a cup, and then either a vinyl or acetate strip. It tells you and reminds you that protons cannot move. So remember, you're going to have protons all the way through your strip and throughout your meter stick. The thing you have to pay attention to is if there are more or less negatives in here. So either your vinyl or your acetate, it tells you whether it's positively charged or negatively charged. And then where you place your negatives in the meter stick, because remember, the meter stick will have the same number of negatives as it has positives. So here, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to need 10 negatives, 10 electrons. The thing that changes is where I place them. If this is positively charged, then they'll all be down at this end because, or mostly be down at this end because they're attracted to that positive charge. If this is negatively charged, most of my 10 electrons are going to be at the far end because they'll be repelled by this negative charge. So there's two questions like this. I do expect to see your protons throughout your stick and throughout your, throughout your meter stick and throughout your acetate or vinyl. The only thing you change is how many electrons you have and the placement of those electrons. So remember, opposites attract, likes repel, and neutral objects are attracted to charged objects. Beyond that, I hope you had a great long weekend. I hope you have a great week this week, and I'll talk to you guys next week.